to the next session of ANSYS APDL. In this session, we are solving another numerical on calculation of SF and BM diagram using ANSYS APDL. So this is a numerical that we are solving. Here there are three elements and it is subjected to uniformly distributed load. It's a cantilever beam. We'll start with preferences, structural, okay, preprocessor, element type, add, edit, delete, add, beam, to node, okay, close. Then I'll go to material properties, material model, structural, linear, elastic, isotropic. I'll get the value of Young's modulus as 2E5 and Poisson's ratio as 0.3. Close this. Next I'll go to sections, beam, common section. The breadth is say 30 and height is say 40. Okay. Then I'll go to modeling, create key points in active CS. The first node is at 0, 0. The second node, I can see here it is at 2 meter. So this will be 2000. Apply. The third node is at 3 meter from the start. So this is 3000. Apply. And the fourth node is at a distance of 6 meter from the start. So this is 6000. Okay. So these are the four nodes. Next I'll go to lines, straight line. I'll click on 2 points at a time to form the line. Okay. Modeling is done. Next I'll go to meshing, size control, manual size, global, size, number of divisions are say 10. Okay. I'll go to mesh, lines, pick all. So the entire meshing is done. Now I'll go to plot controls, numbering, and I want to see the element numbers. Okay. Next I'll go for loading, define loads, apply, structural, displacement. Since it is cantilever and end A over here is fixed, so all degree of freedom 0. Next I can see that in AC portion and DB portion there are two UDL. So I'll be applying pressure in APDL and this value is 3 kilonewton per meter. So this means it is 3 Newton per mm. Same way here the value is 2 kilonewton per meter, which means it is 2 Newton per mm. So let's apply the value now. I'll go to pressure on beam and I'll select the first portion of the beam. Okay. I'm applying the pressure in the y direction. So load key is 2 and the value is 3. Apply. So I can see on the first portion AC and next I'll apply on the DB portion of the beam. Okay. Here I'll choose 2. Okay. So the loading is done. You can check over here. Next I'll go to solution, solve, current LS. Okay. Solution is done. Close this and I'll go to general post processing, plot results, deform shape. I want to see the deformed plus undeformed shape of the beam. Next I can go to contour plot and see the nodal solution, degree of freedom, displacement vector sum. I will choose deformed shape with undeformed model. Okay, so this is showing me the deformation over the beam. You can check the values over here. Next I'll go to nodal solution, stress, and I want to see the von Mises stress over the beam. Okay. If I want to see the SFD and BMD, I'll go to element table, define table, add. I'll choose by sequence number 3, by sequence number 6, by sequence number 16, and by sequence number 19. Okay, so I have all the 4 here. Close. Then I'll go to plot results, line element resolution. I'll choose 3 and 16. This shows me the BMD over the beam. So here I can see the value is 0.318 into 10 raised to 8. This unit is in Newton and mm. So this will be approximately 6 less from it. So this value is 31.8. And here I have obtained the value as minus 33. So it's close. And accordingly you can see all the other values over the beam here. Next I'll go for SFD. So I'll choose 6 and 19. Okay. So this is giving me the SFD over the entire beam. This is the blue one, which is showing the first node A. So here I can see the value is minus 11.7 because this is in Newton. So here my results are in kilonewton, 12 kilonewton. So this is given as minus 11.7. So it's close to 12. And the last value here I can check is minus 300. So it becomes 0.3. So it's close to 0. Now if you want to see the value in between over here, that also can be checked. Here the value is 6 kilonewton. I am getting the value as minus 6.6 kilonewton. So again it's approximately close. If I want to see the other results, I can go to list results, nodal solution, degree of freedom, displacement vector sum. Okay, so here I can see at every node the displacement values. Okay, I can now go to reaction solution. Okay, so here I'm getting Fx, Fy, Fz. Now this Fy is nothing but the force obtained in y direction. It is 12 kilonewton. You can see here. And the moment value is also given. Now if I want to see the nodal loads, okay, so here I can see the nodal load at each node on the beam. So this gives you collective results. So with this I end the session. I hope you have understood the procedure for solving this numerical. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.